Our next essential question is, how do I write and identify solutions to inequalities? So an inequality is a statement that compares two expressions using one of these symbols. So if it's an inequality, you are going to see things like greater than, less than, greater than or equal to. When you see that little line underneath, that means or equal to. Less than or equal to. And then it could also be, not equal to. You could have an equal sign with a slash going through it. So take a look at the examples on page 219. X is greater than 7. So whatever x is, it's greater than 7. It might be 8, it could be 9, it could be 1,000. We just know x is greater than 7. The next one, 7 is less than 5 plus 4, which that makes sense because 5 plus 4 is 9, and 7 is definitely less than 9. B minus 1 is greater than or equal to 12. So whatever B is, if you take away 1 from it, you're going to get a number that's greater than or maybe even equal to 12. For example, the number 15 might work. 15 minus 1 is 14. 14 is greater than 12. Maybe it's 13. 13 could be B. 13 minus 1 is 12, and even though 12 is not greater than 12, because it has that line underneath, it could be equal to 12, and that works. Same thing applies to the next one. 10 is less than or equal to 2 times W. Or the last one, 6 divided by 3 is not equal to 1, which is true, right? 6 divided by 3 is 2, and 2 is definitely not equal to 1. All right, so if we continue on page 219, we're going to do a few of these together, and you can do the rest on your own. Write each statement as an inequality. So number 1 is 3 is greater than or equal to t. So I'm going to start with 3, and then it says greater than or equal to. So here's the greater than symbol, but because it says or equal to, I can put the line underneath, and there it is. 3 is greater than or equal to t. The next one, number 2, 60 is less than, so there's my less than symbol, 8 times 8. 8 times 8. When you move on to the bottom section, you're going to write each inequality using words. So this time, the inequality is given to you in the numbers and the variables, and you have to put the words in. So number 6, well, just the way you would look at it. 4 times m is less than or equal to 16. Number 7. 7, wow, lots of 7. 7 times 7 is greater than 7 plus 7. So that one's just a greater than. There is no or equal to option there. Okay? And on page 220 now, we're going to look at some real-world inequalities and kind of use them in, real-world situations. So the first example in this situation, children younger than 3 years old are admitted to the amusement park for free. So there's our situation. What does that mean? That means any kid whose age in years is less than 3 is admitted for free. So what would that look like as an inequality? Maybe we'll use A for the child's age in years, and A, the age, must be less than 3 in order for the kid to be admitted into the amusement park for free. So that means the kid could be 1 year old, they could be 2 years old. 3 wouldn't work because they have to be less than 3, not equal to 3. So A is less than 3. In example 2, everyone in the class got more than 7 points on the quiz. Well, that means the quiz score of each student in the class is greater than 7. So if Q is going to represent the quiz score, Q is greater than 7. So the quiz score, most people might have, I shouldn't say most, but students could have gotten 8, students could have gotten 9 points, students could have gotten 10 points. I don't know how many points this quiz was worth, but the Q could represent a variety of numbers. It just can't be 7 or less. It's got to be greater than 7. And then here's some other situations with the greater than or equal to, less than or equal to inequalities. In example 1, you must be at least 50 inches tall to ride the roller coaster. So maybe they're back at the amusement park and you must be at least 50 inches tall. Well, what does that mean? Even though it says at least, that doesn't mean less than. It means that your height must be greater than or equal to 50 inches to ride the roller coaster. So when they say at least 50, that means the smallest height you could be is 50 inches if you want to ride the roller coaster. So if H is going to represent the height in inches, obviously we used our units of measure, you would use the inequality H is greater than or equal to 50. Your height must be greater than or exactly equal to 50 inches in order to ride the roller coaster. Anything less than 50 inches, you wouldn't be able to go on the ride. Example 2, children 3 years old or younger can ride the train for free. So think about it. Any child whose age in years is less than or equal to 3, right? If you're 3 years old or younger, so maybe you're 2, maybe you're 1, or maybe you can even be 3. As long as you're 3 or younger, you can ride that train for free. So this time, I might use the less than or equal to symbol. The age in years, you must be less than or exactly equal to 3 years old to ride the train for free. There's a couple words, this isn't in your book, but I want you to watch out for this. This is really important. Watch out for these words and phrases because they're going to tell you, what inequality symbol to use. So if I say, well, one that you saw earlier was at least, right? We saw that in this situation. At least means the smallest number could be, a certain amount. That means it must be greater than or equal to, whatever the situation is. So at least is greater than or equal to, which means, if you think about the opposite, at most would be less than or equal to. At most, meaning no more than. So preferably less than or equal to a certain number. Other words and phrases you want to watch out for is minimum and maximum. Minimum means the smallest number could be this. Preferably we want something greater, so greater than or equal to. Maximum, that means less than or equal to. Maximum means the most, at most. So you don't want to go over a certain amount. You want it to be less than or equal to a certain amount. So those phrases, definitely remember those. Okay. On workbook page 222, we're going to do some of these together. We're going to talk about solutions of inequalities. So if an inequality has a variable, then a solution of the inequality is a value that can be substituted for the variable to make the inequality true. So basically a solution is like a possible answer, an answer that makes the inequality true. Take a look at number 16. One solution of x is less than 15 is x could be equal to 9, which makes sense, right? 9 is less than 15. So x is a possible solution or a possible answer for that inequality. Find two more solutions. Well, basically x just has to be less than 15. So maybe you might say, okay, x equals, there's my equal sign, x equals 14. That could be a possible solution. That could be a possible answer. Maybe x is equal to 2, right? 2 is less than 15. You don't have to use my numbers. You can use any numbers you want. As long as they're less than 15, then they are possible solutions. You can even go into the negatives. You could say x is equal to -5, because -5 is less than 15. So these are all possible solutions. Now we're going to skip to number 18. Is n equals 5 a solution of n is greater than or equal to 5? Explain. Meaning, could n be 5 in this situation? In this case, yes. Yes, n equals 5 is a solution because n must be greater than or equal to, which it is, or equal to 5. And of course that fits because 5 is obviously is equal to 5. Okay, so here are the takeaways for 5-14a. In inequality, we have the definition here. I have the different symbols. If you forget, which one means greater than, which one means less than. And then also, solutions of an inequality is a value that can be substituted for the variable in an inequality to make a true statement. So a possible answer, what your variable could be equal to. Because with inequalities, you could have multiple answers. There's not always just one answer. There's lots of numbers that could work. And that brings us to our last point. There can be multiple solutions to an inequality. You can substitute a possible solution in for the variable to see if it makes the inequality true.